up? What up? I'm the math teacher Goat, and today in AP Precalculus land, we are going over a full lesson of section 1.13, function model selection and assumption articulation, which basically you might as well call it section 1.13. As usual, like and subscribe. The notes for this can be found under the description, so if you want to download those and print those out, you certainly may. Big heads up, this is a very calculator-heavy problem, or section, so we are going to exclusively use the TI-84 Plus graphing calculator. If you do not like or do not use the TI-84 Plus graphing calculator, I'm sorry. But moving on, let's get right into it. Warm up based on previous material is the table linear, quadratic, cubic, or neither. So let's see, we go from -1, and then we're going to add 1, and then we're going to add 3, and then we're going to add 5. So this is not linear. Is it quadratic? Let me see. Add 2, add 2, add 2. It's quadratic. All right, now this section is about real life problems, domain restrictions, and things that are real. Okay, so in order to understand what we're dealing with, let's take an open box top, which is to be made of this piece of cardboard. You're going to remove this square, this square, and that square from it. All right, an open top box is to be made from a 24 by 36 inch piece of cardboard by removing a square from each corner of the box and folding up the flaps on each side. So you remove a square, we'll call the length X, and you're going to do the same exact size square from each of them. Okay, you're cutting out X size squares. Then what you do is you fold it along that line, 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 and you end up making yourself a box looks a little something like this. Okay, ignore my terrible ability to draw. Now, as you fold it up, this is what we know. Okay, if you are going to remove X corners, and let's just say this whole thing was 36, this part right here is going to be 36 minus 2x. That's the length of it. So we'll call you 36 minus 2x, whatever that x may be. Similarly but different, this side, if that's 24, this chunk is 24 minus 2x. So we'll call that length right there 24 minus 2x. The height of the whole thing is going to be x, so we'll call that x right there. Now the question that's being asked is, could you cut out squares of 13 by 13 inches? Why or why not? Well, if we did do that, then we would say that the red length here is going to be 36 minus 2 times 13, and so that would give us a height of 36 minus 26, 10. That ain't bad. Pretty tall box. Could you cut out the same thing out of 24 minus 2 times 13? Well, let me see. That's this guy. 24 minus 2 times 13 is going to be 24 minus... Uh-oh. The answer is no. Because if I were to cut out 13 by 13, I'd be cutting out squares that look like this and squares that look like this, and that just simply won't work. So the answer is no, because you're cutting out parts that are too big. So there's a domain restriction. There are certain things that I am allowed to plug in and not plug in. So it looks like if that's going to be 24, I can't choose a square any larger than 12. I can't even choose 12. It has to be like 11.9999 or something like that. Now that really won't be a good looking box if I chose that, but it is humanly possible. So I said that phrase restricted domain a few times. What is a restricted domain? Well, it's basically what you're allowed to plug in and not plug in. Okay, like I can't plug in 55 for x in either of those. A restricted domain in math word problems refers to limitations of the positive input values, usually the x values, of a function or equation based on the context of the problem. The restriction often occurs because some values are not realistic or applicable in real-life scenarios. For example, I would get negatives here, and you can't have negative height. So there are time-based problems, like time can't be negative, so the domain needs to be restricted to x is greater than or equal to 0. Distance or length. Physical distances or lengths must be non-negative, so the domain is often restricted to positive values. That's what we saw up here with length. Contextual limits. In problems involving things like the numbers of people, the domain is restricted to whole numbers or integers since fractional people doesn't make sense. Okay, so we're going to keep that in mind as we answer some of these questions. Now, again, a lot of these problems are very heavy-duty calculator driven, and in fact, almost all of them. And we're going to start out right away by doing this problem with a calculator. A bottle rocket is set up on a picnic table. When the firework detonates, it will shoot straight up and come back down. The height of the bottle rocket is modeled by this function right here. So it's basically going to look something like this. Okay? Since it's plus 3, it starts here at 3, it shoots up, it comes back down, blah, 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 blah. So this is the height of the rocket. This is the time right here. This is the height. As it goes up, it peaks out, then hits the ground. So stuff on the left side of the x, stuff on the right side of this guy won't make sense, whatever. T represents seconds, h of t represents height of the rocket in feet. Let's answer these questions using our graphing calculator right about now. All right, let's do the old bottle rocket one. We're going to go to y equals, and we're going to type in this equation. Now, I know instead of t, we're going to use x's, so don't yell at me. Negative 16x squared, and then plus 64x plus 3. Let's go to graph. And we get a graph. We can see the parabola, and we can see where it ends. But you know what? I'm not a huge fan of this. What I'm going to do is I'm going to make this window a lot smaller. I'm going to squeeze it. What I'll do is I'll set the x value to negative x value to like -1 or something. I'll set it to like 6 or 7, and then we'll guess if it peaks out at like 100. So let's go to window. Let's do -1. So I see just to the left of the y-axis. Let's make u 6. So my graph is going to go between -1 to 6. And let's max this out at 100. And see what happens. There we go. Much nicer. So it shoots, the rocket shoots off. It comes up, comes back down. Yippee-yi-yo-ki-yay. Now, what I'm going to do is I'm going to do problem A, which is asking us to find h of 2. So h of 2 can be done 2 ways. The easy way is, since 2 is a nice number, I can go to my table by hitting second graph and looking at my x value of 2, and there's my 67. If the number was more complicated, like a decimal, then the other way that I would handle this is hit second trace, which takes me to calc, hit 1 for value, and plug in 2. Still get the same number. So h of 2 is 67, and what that means in this context is that our bottle rocket is 67 feet in the air. Now, the question is, what is the restricted domain? What am I allowed to plug in this case? Well, this is time. The domain is time. So I'm allowed to plug in 0, but I'm not allowed to plug in like 50 or something like that. Why? Because eventually this guy will go up in the air and hit the ground. It's going to hit the ground right there, and I need to find out what that value is. Okay, so the way I can find out what that value is if it crosses the x-axis, that means it's a 0. So I'm going to find the 0. I'm going to hit second trace, which takes me to calc, and I'm going to calculate to the 0. Now what I'm going to do is I'm going to get close to it, but I'm going to stay to the left of it. I'm going to stay to the left of it. There we are. So right there is pretty good. I'm going to hit enter, and then I'm going to cross the x-axis like so, hit enter again. Always hit enter for guess. And this is annoying. Whenever it gives you like e to the negative or e to like the negative huge number, that is fancy talk for 0. So annoying? Yes. Very annoying. But that's the part that doesn't even matter. The part that matters is my x value was 4.046. 4.046, which means that this hits the ground at the time 4.046. So my restricted value is going to be between 0 and including 0 and all the way up until 4.046, and we're going to include that number as well. And the reason why we include that number is you're allowed to hit the ground. So we're including that number right there. That's how you did B. What is the restricted range? Well, the range is how high is this going to go and where is it going to bottom out? Well, it's going to bottom out at 0, so that's going to be the easy part. So we'll say 0 and include 0. How high does this go? Well, we need to find the maximum. So let's hit second, calc, maximum. So what I need to do is I need to set my calculator to the left of the maximum for the left bound. So that's why I'm going left a bunch of times. So the left of the maximum. So I just passed the maximum. So for left bound, I'm to the left of it. For the right bound, I'm going to go to the right side of the maximum, like so. For guess, always hit enter. And for the maximum, we get a terrible number, but it's actually, no, it's not a terrible. I'm sorry, I was looking at the x value. It's 67. How about that? Which means the height peaks out at 67, and it does equal 67, so we'll bracket that. All right, we'll bracket that up. D is asking for the average rate of change for the interval 2, 3. All right, so what I'm going to do is I'm going to get those values and then do the rest by hand. So how do I get the values for 2, 3? Well, let's go back to our table. And our table says at 2, we are at 67. So I already know that. At 2, we are at 67. And at 3, we're at 51. Okay? So let's use those points. Let's use everything that we did and write down what we came up with, write down our findings, and try to understand what everything means. Okay, so h of 2 we found out to be, h of 2 is 67. And what that means is at that moment, the height is 67 feet up in the air. The bottle rocket is 67 feet up in the air. Okay, you plug in 2, you get a height of 67. What is the restricted domain? Again, that meant what are we allowed to plug in? Well, we can only plug in from the moment it fires off to the moment it hits the ground. And we said that the moment it fired off was 0. We're allowed to include 0. And the moment it hit the ground was a terrible decimal, but we rounded it to 4.046, and we can close that off there because we are allowed to hit the ground. Then the question was, what is the restricted range? Well, we are allowed to have 0 where it hits the ground, so 0. And then it peaks out right here at what was 67. Whereas the kids say 6, 7. I don't get it. I really don't get it. I think it's stupid, but kids say 6, 7 all the time now. It's 2025. What is the average rate of change for the interval 2, 3? Well, for the interval 2, 3, we came up with two values. Okay, first off, if I want to find the average rate of change, you're going to do h of b minus h of a. Now, I know we usually use f, but I'm using h here, b minus a. Okay? You would be my a, you would be my b. According to our calculator, we found out that, see, I did it already, h of 3 was 51, and h of 2 was 6, 7. So this ends up being h of b, which is h of 3, which is 51, minus h of a, which is h of 2, 67, over b minus a, which is 3 minus 2. 3 minus 2 is 1. That's nice. 61 minus 67 is going to be negative 16, and that simplifies out to negative 16. Now that means it's, so at 2 we were at 67, at 3 we're at 51. That means we're decreasing in height, so this is going to be negative 16 feet per second. Okay? All right. All right. No calculator for this one, just a really ugly problem. The graph of F below shows the price of generic high school's yearbook. Oh, generic high school. Go fakes. Go fighting fakers. Go fighting pretenders. The yearbook sells for $40 for the first months of school, the first 5 months of school. After that, the price increases every month. So we are given this step function. So the first 5 months we're at $40. Then from the 5th to the 6th month, we're now at $50. Then $60 for a month, and then $70 for a month, and then $80 for a month. That's what this means. At no time does this yearbook cost $40. At no time do we go beyond the 9th month. This is what this means. What is the domain in this context? Well, the domain is left to right. So as we move left to right, we start out at 0, and then as we move to the right, we jump up. But we still count it. 7 or 5 rather is still counted. So even though 5 has a hole here, it's included there. So 5 is never skipped. Neither is 6, neither is 7, neither is 8, but we stop right before 9. So we go from 0 to 9, and since that's a hole, we're not including 9. What is the range in this context? Well, the range are all the y values that we could have. So I can have 40, but I can't have 41. I can't have 45. I can't have any of those. So I have 40, 50, 60, 70, and 80. So we will say y equals, and maybe, well, this says f of, so I'm just going to stick with y equals. Y equals 40, comma, 50, comma, 60, comma, 70, comma, and 80. Find out f of 5.5. So what that means is if we were to plug in 5.5 into this graph, what will we get? So here's 1, 2, 3, 4, 5, and a half lives right there. So I'm traveling up, and I'm going to the second step here, which lines up with 50. So f of 5.5 equals 50. What does that mean? That means if someone were to buy a yearbook after 5.5 months, they would spend $50. That's what that means in this context. Okay? Generic high school. Oh, the problems you get when you steal it from the internet. All right, I am going to use a calculator for that one. Yeah, I am. And the reason why I thought about it is plugging in 2 is going to be a pain, but it's not a world killer. Finding the average rate of change over an interval of 1 is not that difficult. I'll show you how to do that on a calculator. But here's the thing, the maximum amount of Painkiller is what's going to get us. So I'm going to throw that into your TI-84 Plus. Okay. We'll play around with a few things, and then we'll see what happens. All right, the Painkiller problem, when you graph rational functions like this, you have to be so careful of like what your fraction looks like. I like to wrap my entire numerator in a parentheses. So that's going to be 2, I know it's t, but we're going to use x squared plus 10x, which is a very sweet term. 10x sugar, look it up. We're going to divide that by parentheses x cubed. So to do cubed, you can do math 3. That'll get you cubed. Plus 1. Close it. And see what this graph looks like. Now we're talking about Painkiller over time. Okay? So if I hit graph, yuck. Now here's the thing. I don't need anything that has to do with a negative x value. And these numbers aren't that bad. So what I'll do is I'll cut off this value. I'll cut off the x at -1. And since you can't have negative Painkiller in your body, I'll cut off the y value at -1 as well. So let's go to window. Let's call the x min -1. And we'll call the y min -1. And that'll just get us a nicer looking picture. Not that it's necessary, but that's a whole lot nicer to look at. Find P2, explain the solution in context. So again, like I did with the last problem, I could do second table, go to 2, and it's a god-awful mess. 3.11111. It's actually not that bad. It's just, 3.11111. Okay? Now, what that means in this context, right, is if we're talking about Painkiller in milligrams, that means after 2 hours you have 3.11 milligrams of painkiller in your system. So I will make sure that when we write that out, we say that using words like that. What is the average rate of change from 1 to 2? All right, so if I go from 1, I don't have 1, but I have 2, which is 3.111. Okay, I have 1, which is 6. So if I were to set this up, it's f of 2 minus f of 1 over 2 minus 1. So I'm doing a lot of mental math here. Okay, and I'll explain this better when I write it out. But f of 2 minus 1 is going to be u minus u. Then divide that from 2 minus 1, which is 1. So really all I need to do is do 3.111 minus 6. So let me get out of here and do 3.111 minus 6. Hit enter, and that gets me negative 2.889. Okay, and in that case, explain your solution in this context. That means you are losing between hours 1 and 2. You are losing 2.889 milligrams of painkiller in your bloodstream, and we'll talk about that in a minute. What is the maximum amount of painkiller? Well, according to the graph, it peaks out and then it levels off pretty quickly. I need to find that peak. We've done that before. Second trace takes me to calc, and we're going to hit 4 for my maximum. Let's go to the left of the maximum value, like so. I'm doing it now. Moving to the left, there we are. Hit enter, move to the right of my maximum value, hit enter, and it's going to give me a time that doesn't really matter because it wants the maximum amount, and the maximum amount is 6.161. So 6.161 is going to be my maximum. So let's go back. Let's answer those questions and make sure that we're very peculiar and particular in any other word that starts with a P. Like painkiller. Ooh, if I were making painkillers, I'd call it forget it. Let's just go back. Okay, P of 2 ended up being 3.1111. So P of 2 was 3.111. And what that means is after 2 hours, why did I put that over there? So we'll write it out like this. 3.111 milligrams will be in the bloodstream after dose hours. Dose. Painkiller. That was funny. I was nailing the puns today. What is the average rate of change from T1 to T2? Explain your solution. All right, well, we kind of figured out that, look, we would do P of B minus P of A over B minus A. The easy part about this is if I call you A and I call you B, which is what we would do, I get 2 minus 1, which is 1. So we used our calculators to find out that P of B was, I believe that was a 3.111, and P of A was 6. When I plugged in 2, I got 3.111. When I plugged in 1, I got 6. We ended up then getting negative 2.889 over 1, which is negative 2.889. Now, what that means in this context is you lose 2.889 milligrams in your bloodstream, another pun, between hour 1 and 2. All right. And this one was the nice one. What was the maximum amount of painkiller? Well, that would be 6.161 milligrams. Okay. All right. Let's keep on trucking. Another calculator problem. I mean, all of them have been except for that one step function one. The value of stocks on the market typically fluctuates over the course of a day. Suppose a particular volatile stock's daily value can be modeled by that gross polynomial right there, where H represents the hours after the stock market opens up and for early trading. The stock market is open for 9 hours, so the domain is H is in between 0, including 0, but not including 9 for some reason. Approximately how many hours after opening does the stock reach its lowest value for the day? So this is a simpler calculator problem. Don't have to do near as much as the others. I just need to graph that and find the minimum. So let's go do that now. All right, so we are going to plug u in. Of course, instead of h's, we're going to use the x. So x to the 5th minus 20. Up. After you do your exponent, I deleted the whole thing. That's all right. X to the 5th. And after you're done with your exponent, make sure you hit to the right to get out of the exponent. So I'm glad that happened. Minus 20x to the 4th. Move to the right. Plus 146 x to the 3rd. Of course, you could do math 3 if you want to for that. Minus 484 x to the 2nd, which I could have just done that button over there. Oh well, too late. Plus 717h, which is x, and then plus 15. Now my domain is between 0 and 9, so why don't I go over here to my window and change my y minimum to -1 so I can see just to the left of it, keep it at 10, and since we're talking about like real life stuff, let's change our y minimum to -1 because I really don't need to see a whole lot of stuff underneath the y-axis. Okay? Graph. Okay. I don't see much of anything right there, which means this graph is huge. So what I'm going to do is I'm going to change my window and change the y max to 100 and just see what happens. Didn't do me any good. So let's change it to 1,000 and just see what happens. Hey, there we go. Now my job is to find the minimum value, okay, after 9 hours. Or within 9 hours. It appears that that's going to happen right away. Huh. Now, I really wish it was here, but it appears that the minimum is going to happen immediately. Now, let me go back and make sure I typed in the right equation. X to the 5th, yep, minus 20x to the 4th, yep, plus 146x cubed, yep, minus 484 x squared, yep, 717x, yep, 15. All right, so I didn't do anything wrong. It's just that as much as I wish this would have happened, I probably should have created the problem where I care about what happens between 1 and 9. But it's too late. The minimum value is going to happen right away. So if I know the minimum value is going to happen right away, why don't I plug in 0? Or see what happens at 0. So at 0, I have 15. So how many hours after its opening does this stock reach its lowest of the day after its opening? Well, immediately. Okay, immediately. So I don't like that. I don't like the way I set this problem up. But let's just do this. Let's adapt the problem and say, all right, well then after an hour or after 2 hours, when is it its minimum? Because I really want to use the minimum function just for funsies. Okay, second trace 3 lets me take a minimum. I'm going to go to the left of the minimum. Again, I'm just doing this for fun. I'm going to hit enter. I'm going to go to the right. I'm going to hit enter. I'm going to hit enter again. And it gives me a minimum of that. So that happens at 9.110 hours. And that whatever that means for the stock market is whatever that means. But in reality, the answer for this one with this very flawed problem that I created on my own is immediately. So let's go back and say we've wasted our time immediately. All right, so even though the problem I came up with, I'm not happy with at all, that's okay. The reality is we did a little bit of extra just to make sure we understand how to do the minimum things. And what happens is this just falls apart immediately. I don't think that's how you spell immediately. So how about like right away? I'm not here to spell correct. I ain't here to spell good. I'm just here to do math. And I barely do that right to begin with, too. All right. Oh, we're just moving along. Next page. Okay. A cannery company needs to find a way to maximize the volume of their 32-ounce cans. Volume! Which type of function is most likely to model the volume in this situation? Well, that would be cubic, of course, because if you're talking about the volume of a can, you're talking about volume, which is pi r squared h. So u times u times u. So this is going to be a cubic function because volume is measured in cubic units. That one wasn't bad at all. The piecewise function f shown below models the insulin levels of a patient over time where x equals 0 represents 8 o'clock. All right. So here's your picture. So we're going from 8 to 6, it looks like. So my range is going to be from 0 to 10, which represents 8 o'clock to 6 o'clock. So you choose the answer you want. My range is going to be from 8 all the way up to 24 and including, so 8 to 24. Find f of 3. There's 3. F of 3 is going to be about like what appears to be 24. So that means the insulin level, so that means 3 hours later? So at 11, the insulin level is, 24 mononucleosis units per milliliters. I don't know. Find the average rate of change from 0 to 3. Explain the meaning in this context. All right. So basically we have 0. 0 is 8. So 0. So if I were to say you're A and you're B, f of A is 8. F of B is 24. So using the average rate of change formula, which is f of B minus f of A over B minus A, I get 24 minus 8, which is 16 over 3. So what this means is your insulin, I'm not going to write out that abomination again. What this means is your insulin level raises, I am going to write it, MCIU or MCLU or whatever, per MCL or ML per hour. And that raises at that rate per hour over the first 3 hours. Okay? Okay. Oh. No. Okay. So I'm not using a calculator for this one. That's going to be the next lesson. Okay, that's going to be the next lesson. A toy rocket is launched straight upward from the ground. The table shows its height above the time after t, or the ground after t seconds. We know what's going to happen. We know that this is going to be quadratic, but let's just see why. You add 18. Okay, you add what is that? 16? No, that's 14. You add 10. Add 18, add 14, add 10, add 6, add 2. Is it linear? No. Is it quadratic? You subtract 4, subtract 4, subtract 4, subtract 4, so it's quadratic. So basically what I'm saying here, and I'm not going to write it out because there's a lot to write out, I'm assuming the relationship between the variables could be modeled by a parabola and that this pattern will continue the same way beyond these given data points. So At some point, I am going to hit the ground, though, so not like completely beyond the given data points. But one assumption that I can make is that this is quadratic, it's a parabola, and the pattern keeps on going. Okay, so that's how I'm going to answer that. That's how I'm going to answer that. All right, so we have some multiple choice examples. Okay, let's get through these. Now, by the way, no. I'll get there. I'll get there. Yep, I'll get there. I'll wait until the end of this problem to say what I needed to say. Oh my gosh. Oh. All right, this is going to be awful, but let's just do it. All right, to get from 97 to 405, and I didn't even leave myself space. You're going to add 308. From 405 to 977 is 572. 884. 1244. 16. Yeah, 52. Oh, the year I was born. All right, well, it's not linear. So let's see what the next ones are. We've got from that to that is you're going to add 264. Then you add 312. Then you add, let's spin it around and do a nice 360. And that one's 408. So it's not linear. It's not quadratic. Is this guy going to be cubic? Yay, because you go up by, yeah, you're going to go up by 48. You're also 48. Oh, thank you, baby Jesus. You're also 48. All right, so this is cubic. So the function is a quadratic? No. The function is a quadratic? No. The function is a cubic because the second differences are a non-zero constant? No. It's because the third differences are a non-zero constant. All right, so this is a very bizarre problem, okay? Very bizarre problem. I don't like it. I don't like it at all. This is what we can find out. Okay, this is what we can find out. If I know that the average rate of change, right, so f of b minus f of a over b minus a, if I know in this case it's going to be 34, okay, I know that I'm going from, so you would be my a, you would be my b. I already know that f of b is 405. So I have 405 minus f of a over, let me see, what did I say b was? 4 minus negative 22 equals 34. That would give me 405 minus f of a over 26 equals 34. If I multiply both sides by 26, that gives me, let me see, 884. So 405 minus f of a is 884. Subtract 405, negative f of a is going to be 479, which means f of a is negative 479, gross. So I'm going from negative 479 to 405. So there must be at least 1 0 on that interval? Yes. What a stupid problem. Boy, did I not like that at all. I told you this. I told you the fart noise at the beginning was very accurate. All right. A function model T, like the car. Oh, I'm sorry. A track athlete is running laps. Cool. The graph shows the average rate of change from the previous lap. So, okay. A function model T is constructed for the time of each lap. Which of the following statements best supports the selection of the model for T? Okay? Since the rate of change is roughly linear, a linear model is best for t. Since the rate of change is roughly linear, a quadratic model is best for t. Since the rate of change is roughly linear, a cubic model is best for t. Since the rate of change is negative and positive, a quadratic model is best for t. Well, thanks for watching. Hated that. Hated it a lot. We did a lot of calculator work, which is very important, but all in all, hated the whole dang thing. Thanks for watching, though. Make sure you like and subscribe. Make sure you also go to my math teacher goat YouTube and type out 1.13 AP Precalculus 1.13 and watch my random AP Precalculus example videos. They'll just give you a little extra oomph, help you understand everything. Okay? One more to go, and then this unit is donezo, baby. Thanks for watching. Love you all. Stay blessed. Bye.